All right, we're going to pick up with variations in incoming solar radiation. First of all, incoming solar radiation is just kind of a technical way of saying sunlight. Variations in sunlight, okay? So all of that just really means sunlight. Okay. In surface waters, in addition to nutrient supply, which is discussed elsewhere, the autotroph population varies with the ability of incoming solar radiation that powers photosynthesis. Okay? What that means is your autotroph population, like for instance in a marine ecosystem, your autotrophs are your phytoplankton. Okay, so phytoplankton populations are going to depend on how much sunlight you have. That's basically what that sentence says. Okay? Because autotrophs form the base of most marine food chains, seasonal variations in incoming solar radiation also have implications for the populations of organisms occupying higher trophic levels. Okay. In normal people terms, what that sentence says is because phytoplankton is at the base of your food pyramid, or energy pyramid, and at the base of your food chain, then whatever is happening to your phytoplankton population, that's going to kind of determine what is going to happen to all of the other, like the heterotrophs that depend on the phytoplankton. So if your phytoplankton population goes up because there's lots of sunshine and lots of nutrients, then it's going to also mean that your heterotrophs will have a chance for their populations to go up. So basically that's what those first two sentences mean. In this portion of the investigation, we consider the influence of variations in incoming solar radiation on marine productivity. Okay? All right, so we're going to highlight a couple of sentences. Okay, and just to prove that you're actually listening, right out to the side over here that marine autotrophs are phytoplankton. Okay, so remember, sunlight is going to determine how much phytoplankton you're able to have, and how much phytoplankton you have is going to wind up going a long way towards determining how many of the heterotrophs the food web can support. So anyway, all right, so now we're going to examine Figure 1. And it also appeared in a different investigation, but that's not an investigation I don't think that y'all did. So data points on the graph are going to represent the monthly average measurement of solar radiation, basically, okay? And we have 3 locations. We have an equatorial location, which is represented by Singapore, which is only a few degrees off of the equator. We have a middle latitude location, which is Brockport, New York at 43.5 degrees north. And we have a high latitude polar location, which is in Russia at 80.5 degrees north. Okay? On the graph that we're about to do, the month of the year is going to be plotted along the horizontal axis, and the average daily incident radiant energy is going to be plotted on the y-axis, okay, or the vertical axis. Okay, so first of all, month is going to be on the x-axis, x is horizontal, okay? Average daily incident radiant energy, that's a mouthful. I want you to take your pencil. First of all, vertical axis is your y-axis, but point to this up here, average daily incident radiant energy. That is a really big way of saying sunlight, okay? Basically, what you're doing is you're plotting the month of the year on the x-axis, and you're plotting sunlight on the y-axis. That's what we're going to do. And we're going to do this for 3 different locations, okay? We're going to use green for Singapore. We're going to use red for our middle latitude, Brockport, New York. And we're going to use blue for our high latitude polar location, okay? Okay, so I just shaded over. My equatorial is going to be green. My middle latitude is going to be red. My high latitude polar is going to be blue. Okay, now we are assuming that the values of radiation given for each of these three locations are representative of ocean locations at the same latitude. Okay, so they took the data from actual cities, and obviously the cities are located on land at those latitudes, but what they're saying is they're assuming that you're going to have the same amount of sunshine at that latitude in the ocean as well as on the land. Okay, so that's the one assumption that they're making. Okay, it asks us to reproduce the curves that you drew in Investigation 5B, which we didn't do, by drawing on Figure 1 a smooth curve connecting the little dots or diamonds or triangles or whatever. So that's what we're going to do first. Now, I do want you to highlight right here where it says, note that at the high latitude polar location, radiation values are 0 or nearly 0 for 5 months out of the year. That's going to be your blue line. Okay, so let's just go down here. I'm going to zoom out just a little bit. Okay. So the first thing we need to do is connect our points. I've already got blue in my hand, so I'll just go ahead and do that. That's the triangles. Okay, it's not perfect, but it looks good enough. The red dots are your middle latitude. That's the Brockport, New York location. Oops. Okay, and then the green is your equatorial location, which for us is Singapore. Okay, so you should get something that looks similar to what I've got. Okay. Okay, so there are my 3 lines. I'm going to zoom out just a tad. And what I want to do is I want to go up and address the 2 questions 14 and 15. Number 14 says, according to the curves that you've drawn, the average daily solar radiation varies the least over the period of a year at what location? Okay, so what they're asking is which line down here varies the least? Which one has values that don't change very much? Okay. On the green line, your highest value seems to be about here. Your lowest value seems to be about there. That's not a whole lot of change. You know, it's whatever this is from here to here. Okay. Your red, the highest value seems to be about here. Lowest value seems to be about there. So that's a bigger change. And blue, your highest value is here, and your lowest value is all the way down at 0. So that's probably your biggest change. Okay, so according to the curves you've drawn, the average daily solar radiation varies the least at the green location, which is your equatorial location. Okay, and that should make sense because we get plenty of sunlight all year round at the equator. Okay, it varies a little bit, but it doesn't vary a great deal. At the poles, remember there are some times of the year near the North or South Pole that they don't get any sunlight at all. So the amount of sunlight that you're receiving towards the poles can vary a whole bunch. So number 14, you should go with the equatorial location. Number 15, the average daily solar radiation varies the most, And we just talked about that. It varies the most at the polar location. Okay. And then here's what we're going to do. We are going to compare the annual range of solar radiation received at the 3 locations. Okay, so what I'm going to do is I'm going to go ahead and I'm going to stop, and we will pick up with that question on the next screencast.